Something I noticed when offering support on one of my assets is that a lot of people seem to be struggling with the idea of events and event listeners, specifically when it comes to Lambdas and anonymous methods. So I wanted to make this video, hopefully demystify them a bit, talk about how to use them, why to use them, some things to look out for, stuff like that. So I have made this little unit builder example scene where we have a button that says build unit, and when we click it, we're going to be building a unit, courtesy of Mix and Jam. It's our good friend Jamo. We have this label that goes from waiting to building to done, and then we have this light that will go to orange, and once it's done, to green. Awesome. So the way I have it set up now is what I would call sort of the quote unquote naive way. And it's not necessarily a bad way. Sometimes this is totally fine, but let's pretend for a second that this unit builder is, maybe a little bit more involved, or maybe you just want good, clean code. Right now, this unit builder is not just building units. It is concerning itself with the label, it's concerning itself with the mesh of the light, it has these color settings in it, and it shouldn't have to do that. And so one thing we could do that people say, well, this could fix it, is like take all of this stuff, like the mesh renderer and the light data, put it in its own class, status light, and just add a reference to this in the builder instead. And while that is better, you're still maintaining a reference to something that doesn't concern the builder. Because in this example, the builder is sort of the meat and potatoes, right? Like this is where the real logic happens. And the status light and the display screen, those might change. Maybe we get rid of the hollow display screen and make it a label in the corner. Maybe we make it an icon instead of text. Maybe we want to get rid of this light. Right now, when we do that, we're going to get a null reference exception because it's no longer assigned here and our code expects it to. So the way around that is to have this hollow display, this screen, this light be standalone objects and have them be dependent on the unit builder instead of the other way around. So let's take a look at how to do that. First, I'm going to walk you through my code real quick. This is the unit builder. When we click the button, this method gets called, start building. We are instantiating our prefab, putting it in the right position. I am then resetting the material and animating it. Here's a quick thing. I'm using a single material for this. Never do that. This is purely for demonstrative purposes. Always create your own instance of it or use material property groups. Don't do this. And if you're wondering what doFloat is, I am using doTween for this just to keep my code nice and concise. It's a wonderful free library. It's an asset that helps you tween anything under the sun. It's amazing. And once it's done, we even get this onComplete callback. And that's our first callback that we're running into. So once this is done, we are passing in this function, and it's going to call that, which is great. But as you can see, once it's done, it's setting the status label, it's setting the light, it's doing the same here. We don't want any of that. So we are going to be using events. First things first, what is an event? An event is something that you create, and it's going to be a provider. And anything that has access to it can subscribe to it. It can become an event listener. And so once that event fires, anyone listening to it, for example, our hollow display and our status light, can call their own methods, can call their own callbacks. So how do we make one? Well, first let me make a awake method here real quick. And one way that you can do it in sort of pure C# is using the event keyword and then saying action from the system name class. And you can say, my event. And usually you would call this something like onThing happened. And, you can initialize this, etc. We're not going to use that. This is totally valid, but Unity has its own thing that is called a Unity event. And the reason I like those is because they are serializable and they come in the inspector. So you can hook things up in the inspector if you wanted to. We're not going to be doing that. We're going to do everything through code because that's sort of the whole exercise. But we are going to be using that architecture because that is what you'll most likely be using like 99% of the time. when working with Unity. So instead of this, I'm going to create my first Unity event from the events namespace, and I'm going to call this on build begin. And I'm going to create another one and call it on build complete. And now I'm going to run into an issue here with naming because I have tried to record this before. I'm going to call this callback real quick, on build complete callback, because I'm going to take these two and I'm going to create some getters for them. Get rid of the setters. So what does this do? This creates properties that are accessible to anyone who has a reference to this unit builder. They can get to the events, but they can't set them. They can't create a new object for them, which is just a little bit of safety there, a little bit of encapsulation. So the next step is to initialize these things. So we can say on build begin is new Unity event, and the same for on build complete. And we're doing this in awake. So when we attach our listeners, we're going to do that in start so that we know that this has run. So I'm going to go to our hello display here. I'm going to add an awake method to this, all the same. And now we need a reference. So we could make this static, but that's not always a good solution. So I'm going to go ahead and just create another serialized field in the hello display and make it link to the unit builder. I'm going to call it builder. And I'm going to do the same for the status light. Now you may be wondering, what is the point of doing this if we still have these references? The difference is that the hello display or the UI elements can be is perfectly fine to be dependent on this thing existing. In fact, if there is no unit builder, this display has nothing to do. But if there is no display, the unit builder still has things to do. So it's that sort of the separation of responsibilities, separation of concerns. And so this is, we can remove the display, nothing is going to change. We can remove the status light, nothing is going to change, which is just a much better approach to handling this stuff. I'm rambling. My apologies. So in our awake, which shouldn't be awake actually, it should be start, as I just said, we are going to go to our builder. We are going to grab our onBuild begin, and we are going to call our add listener on it. So when we add a listener, it's going to take a Unity action call. And I'm wondering, well, what is a Unity action? Well, very simply put, we can just take this and put that in there, and that just works. And you may be thinking, well, this is just a regular void. That's not a Unity action. This is just a member. This is a function. Yes, but a Unity action is a delegate type, just like system.action, system.func. Basically, it just takes any function that matches the signature. And in this case, it's a simple event with no parameters. So it wants to call a function that takes no parameters. This fits the bill. By the way, this name does not need to match that name. We can just as easily call this foo and everything still works. I just like having them the same because it's immediately clear what's happening when possible. Doesn't need to be. So we are going to do that. We are going to do the same for onBuild complete. And I'm going to just copy and paste this into the status light. And we can use the exact same code there because our methods are called the same, but they're doing different things. The light is setting the light color. The display is setting the label text. And the builder, all that needs to do now is none of this. In fact, oh, my bad. I called this uncomplete callback. We should give it the proper name. We don't need to do any of this anymore. Instead, what we're going to do is we're going to invoke the onBuild begin event. So we're going to call that, and we're going to say invoke. And what that does is it's going to say fire off this event, and anyone who's listening to it will have their listener, their callback, called. And this should, of course, be onBuild complete, not onBuild start, for anyone who caught that before I did. Well done. So we're invoking this event. These things are going to run, and we're not going to worry about the end thing. Well, actually, why not? We can just do the same here. In the end callback, we can say onBuildComplete.invoke. So going back to Unity now, we need to change one thing. We can see that our unit builder just got a whole lot lighter. We have our onBuildBegin and our onBuildComplete, and we can add things to them. And if you've ever used a UI button, you might recognize this because this is the exact same as UI Canvas build button as this thing, the onClick. It's just a Unity event. And so you can pass in your methods here and hook them up in the editor, which is amazing. But going back here, this is now a lot emptier except for the events. We do need to go to our hollow display screen and we need to fill in our unit builder. Let me just collapse this. Go to our status light and do the same thing. And now if we run our scene, hit build unit, the light changes, the label changes, it's complete, and both change again. Cool. What did this really accomplish though, other than being cleaner code? Well, if we say we no longer want this dinky light, we can just eat it away, build unit, and everything still works. Because as far as the builder is concerned, nothing has changed. It's still firing its event. There's just one less person listening to it, or one less object listening. Let's not personify this little light here. But I like it, so I'm bringing it back. But it also means that we can take this status light and we can find it here, we can move it over, and now we have two lights. And we didn't have to change a single thing in the unit builder because we just added another listener to it. And that's totally fine. And no one is all the wiser for it, which is amazing. So this is nice and modular now. Let's keep going with this example a bit. Let's say that in our hollow display, we don't just want to say done. We want to say the name of the unit that we just built. Now our unit builder could store a unit here somewhere, make it publicly accessible, but it might be building more than one unit. So then how do you keep that track of that reference? Well, we can pass it on as a parameter to our events. So the way we do that is rather than just saying a Unity event on build begin, we're going to use these little things that you may know from get components, and they are used for generics. So we're going to create a generic version of this Unity event, and we are going to pass in an instance of our unit class. Now we of course need to change this everywhere, and I'm just going to do that manually real quick. New Unity event, pass in that unit everywhere. And now some things are going to start complaining. Namely that this invoke says there is no argument given that corresponds to the required parameter arg0. We need to give it a parameter. And what parameter is that? Well, the thing we just instantiated. So I'm going to go ahead and just say unit is instantiate. So now we're storing this here and we can invoke it like so. And that's cool because this will just work. So I'm going to comment out this for a second. I'm going to go to the hollow display and I'm going to, because now this is complaining as well. It's like, hey, we can't convert from method group to a Unity action that takes a unit because this method doesn't take anything. So the function signature doesn't match anymore. So all we need to do is say you take a unit, as do you, and we need to do the same here because it has the same complaints. So this is all fine and dandy, and now it's working. And in fact, let's do it here. Let's say building plus unit.name. Go back to Unity, hit play, build our unit, and it says building unit clone, which is indeed the name of our newly created unit clone. So that's cool. We just need to do the same for the end. We just need to do the same for the onComplete event here. But there's a problem here because once we're in this callback, we no longer have a reference to unit. And like I said, we can store this like at the top or something, but that seems a little not very scalable. What if we're gonna make multiple? Well, we can maybe use like a queue and queue them up, but what if one takes longer to build than the other? And oh my God, it just gets complicated. So rather than passing in an already existing method, we're going to create our own. We're going to create an anonymous method. And the way we do that is first, the parameters that it takes in. Well, this uncomplete doesn't take anything. So it's just going to be an empty list of parameters. Then we write this funky little arrow, which is an equal sign, and then greater than, which reads as goes to. And then we do curly braces for our function body, just like a normal function. And then in here, we're just going to do the same. We're going to invoke our event, and it takes a unit. But here, we have access to the unit. So what is happening exactly here? Like this seems a little weird, right? Because we're holding on to that. What's happening is when we create this lambda, this function, that's what these things are called, lambdas, we are also creating a closure. We are capturing this variable. And I choose those words very carefully. We are capturing the variable, not the value. We are holding this function object, this whole thing that we're creating, is holding onto a reference of this unit. And we are passing that in. So even if we call start building again, and we're going to create a new unit, no problem. It's always going to invoke the method with the unit it was meant to carry. So let's do that. Let's go to our hollow display, and let's do the same here and add units.name is done. And just to make sure it works, I'm going to go here, build unit. We're building unit clone, and then it says unit clone done. Sweet. So that's all nice and good. And, you know, we can do multiple things in here. Like I gave my unit a little boot as well. So we can say unit.boot, and now he has glowy eyes. That's cool. But I do want to talk a little bit about some of the downsides of this, because this is really cool and really powerful. But as all good things, there are some downsides to it, unfortunately. The first is that because we are creating a new function object here, we are generating a little bit of garbage. We are allocating some memory to hold it in, then we need to get rid of it later. It's not a lot. It's not something you typically need to worry about. Just don't go around using this all the time when you don't need to, especially in like updates or like maybe in a coroutine every single frame. If you can get away with a normal method, then I would recommend it. But it's also not something like, it can be a little bit of a micro optimization. Try and find a balance. You do you. I'm rambling again. So sorry. It's been a hot minute since I've made a tutorial. But downside two, I'm going to go to a different example, which is in the same scene. I have these simple callback buttons, and it's just a little layout group with 4 buttons, button 1, 2, 3, 4, and they don't have any listeners assigned to them. And then in a simple for loop, I am adding listeners to the onClick event on the button, and I'm logging I. So one thing you might notice here is I don't have curly braces against my statement, and it's just the same how you can do things like, you know, if true, do thing. You don't need them. It's the same with this. As long as your expression is only one call or one instruction long, you don't need them. It just saves a little bit of overhead. Doesn't overhead like, not overhead on the computer, overhead on you scanning or parsing your code. Not the point. The point is, when we run this code, you would expect that if we click the buttons, the first one is going to say 0, the second one is going to say 1, then 2, then 3. What happens in reality is that button 1 says 4, and button 2 says 4, and button 3, and button 4. They all say 4, which is a little strange because I just said that even if we call that same method multiple times, in our unit builder, like it's always going to hang out to that unit. So what is going on here? What's happening is we are creating this integer I inside our for loop. It's going to be set to 0. And then we are passing it here. And this anonymous method, this function object, is going to hang on to a reference of I. Even though it's a value type, it's going to hang on to the reference of I. So the first time this loop runs, I is 0. Then it's going to run again. I gets incremented once. It's now 1. It's going to find the first button, add the listener, etc. I'm going to go do that again. 2, 3, 4. 4 is not less than the length of the buttons, which is 4. It's going to break, and I is going to remain at 4. But I will not be disposed of because uh, our lambdas here are still holding references to I. So that's what's happening. So how do we print 0, 1, 2, 3 as one might expect? For that, we need to shadow this variable. So what we're going to be doing is we're going to be creating a new int here. And I'm going to just call this shadow real quick. Say is I. And instead of I, we're going to print shadow. So what is happening is inside this loop, it's going to run once. We're creating a new int. That's what we're capturing. Then it's going to run again. We're creating a new int. Second callback or second lambda is going to be capturing our newly created int over and over. As for naming these things, I've seen cached being used a lot. Personally, I like to do underscore and then the original name. Some people, especially fans of Hungarian notation, might find that a little bit offensive, but it's all personal preference. It doesn't matter. So going to Unity now, we can hit play. Button 1 indeed says 0, and then 1, 2, 3. I have this little example below that though, where I say for each button and buttons, add a listener, and we are going to use TMPro, get the label and print that. And so you might be saying, well, hey, we're going to have the same problem here, right? Well, actually, no. If I click the first one, it's going to say button number 1, 2, 3, 4. And the reason for that is because in this for each loop, this button is going to be a quote unquote fresh instance every iteration. So we don't need to worry about that. We only need to worry about it with regular old for loops here. Now there is one other downside to lambdas that I want to talk about, and that is going back to our, let's go to our hollow display here. Let's say once a build is complete, we don't want to listen for the next one, right? Well, we can do something very quite simply. We can say builder.onBuild begin, and we can say like, well, this display has done its job. It's done. It doesn't want to listen for anyone else. We can say remove listener. You don't want to necessarily remove all listeners because who knows who else is subscribed to that. But we can say we no longer want to listen to it with our callback onBuild complete. And just real quick, we can listen to the same event with multiple callbacks. Like if we have another callback called onComplete2, we can assign that all the same. Doesn't matter. But we can remove listeners like this. Just throw it in the same function reference. But here's the issue. When we're using a lambda, like we are here, throwing it in this onComplete, there is no reference to it. So that becomes tricky. And you can store references. You can like make a new action. Like you can cast this into an action and use it that way and then keep track of that. But at that point, usually there's better options. Just be aware of that because you will want to unsubscribe from certain events. And if you don't, then you are more than free to use this. But yeah, that's pretty much it, I think. Use events whenever you can because they are extremely powerful and they make your code so much more manageable. Like the fact that this, I mean, we can even get rid of this now. Doesn't need to concern itself with anything else. It's just nice. But let's say you're writing something like the network manager in the new Unity netcode. It has callbacks for when a client is connected or when a client disconnects. You can't modify that netcode, go into that class and say, hey, every time a class or a client connects, try and call my own callback. Like you want to have that be dynamic, and using events allows for that. And so this unit builder just does its thing, doesn't care about anyone else. Hollow display does its own thing. Status light does its own thing. Everyone is just happy. Everyone is focused just on themselves. It's just nice. I need to stop rambling. If you watched this, thank you. I hope you found it informative. I'm sorry for all my umming and stuttering. It's like I said, it's been a couple years since I last made tutorials and stuff. but I do hope to be getting back into it a bit more. I enjoy making them, and uh, yeah, I hope to be posting a bit more again. So if these sorts of tutorials are something that you might be interested in, then do all that YouTube stuff. Like it, I guess, but more importantly, subscribe so you know when there's a new video out. Um, yeah, thank you for watching, and hopefully see you in the next one.